Today we are going to focus on the Enhanced Road Safety Transportation Program. You're going to see a series of small to medium enterprise companies coming together and building real-world innovation. I would like to introduce Sonia Shorey, who is the CEO and president of Invest Ottawa. And the first panel is going to look at enhancing road safety using ADAS, in-cabin sensing, and vehicle-to-vehicle communication. So how data, connectivity, and AI translate into measurable gains in road safety and public trust. Sonia?
Bonjour tout le monde. It's an honor to lead this panel discussion today with so many friends, esteemed partners, and colleagues that we've had the privilege of collaborating with, frankly, over many years. This panel, as Rebecca had shared, is about the digital and infrastructure backbone that powers road safety. Led by Area X.O and operated by Invest Ottawa, this Transport Canada-funded safety project brings together innovators across Canada to integrate in-cabin sensing, advanced driver assistance systems, ADAS, and vehicle-to-vehicle communications. Combined with 5G connectivity and AI analytics, these technologies deliver real-time insight and actionable safety messages that can prevent collisions before they happen, something that is an absolutely critical goal. Safety is our North Star here at Area X. This work builds directly on Transport Canada's Road Safety Strategy 2025 and Vision Zero goals, tackling distracted and impaired driving, reducing fatalities, and building the knowledge and frameworks that are going to shape the future of road safety in Canada and hopefully influence others. Just as important, it showcases the power of collaboration when SMEs, multinationals, municipalities, researchers, and government all working together to create the standards, practices, and innovations that will save lives, that will position Canada as a global leader in safe mobility, and allow us to meaningfully collaborate with and contribute to the world around us. Today, you're going to hear from the esteemed leaders who are a part of this project, the breakthroughs, the lessons, and the path forward to safer roads for Canadians and others. So to all of the esteemed panelists, thank you for being with me. This project integrates, as we've talked about, in-cabin driver monitoring, ADAS, and V2X communication to deliver real-time safety messages directly aligned with the road safety that we're all striving for. From your perspective, what was the most defining or meaningful moment of this project for you and your organization, and why? We're going to start to my right. Welcome. And I'm going to hand over the mic. We're going to share the microphones.
Hi, my name is Alexey Iskrov, and I'm from a company called Traffic. And we were working in that project on a part of the infrastructure, basically having a second set of eyes on top of the intersection using camera and radars. And for me, the moment that it actually hit was when we stopped a truck from camera, and we discussed that moment and this specific scenario for months. But before I actually saw that happening here at the intersection, I couldn't imagine how impressive it is when you have that additional set of eyes and just stopping a heavy truck, hitting the brakes. That was the moment that it actually hit, and I kind of was really impressed.
Amazing. Why don't we go to Omar?
Excellent. Well, my name is Omar Choudhry. I'm Senior Specialist in Intelligent Transportation with the City of Ottawa. And thanks, Sonia, for allowing us to be here. And this is now, I think, our 8th year, basically, that we've been working together.
Yes, long-time partners.
The City of Ottawa has been a long supporter of Area X.O. We were one of the first to be throwing in money when this was still just an idea, and to see where it's come. I think for us, out of this project, our focus is on road safety, right? And so the technology that is forthcoming that can actually prevent vehicles from collisions, saving vulnerable road users. We've had a long history of projects here, vulnerable road user projects at intersection. We've had connected vehicles at rail crossings. We've done the very first vehicle to infrastructure with the BlackBerry QNX now about 7 years ago. Hard to imagine it's been that long.
Goes right
very first automated shuttle on roads in Ontario, and soon to be the very first medium speed shuttle to be on roads. I think, like I said, it's us pushing the envelope and being able to support the ecosystem that we see here to drive the innovation, to drive the economy, but also, selfishly, to make sure that we are on the bleeding edge or leading edge of understanding where the technology is going so that we can prepare ourselves for the future.
We're so grateful for your leadership. Thank you. Colin, it is wonderful to be back with you, a longtime collaborator as well.
Yeah, thank you, Sonia. Colin Dhillon. I'm the lead on business development and strategy for NuPort Robotics. Prior to that, I've worked on smart city projects with Oven, or as it used to be called back then, Avon, the demonstration zone over at the city of Stratford. And I also led Project Arrow, Canada's first electric vehicle demonstration product. But, regarding the project that we did, look, when you're developing autonomous stacks and you're developing autonomous vehicles, transferring your results from digital twins to actual is critical, especially for a company like ours, where we're now commercializing our technology with partners like of Canadian Tire. And so what we'll be talking about in further detail really is about the importance of what we predicted versus what's actual as ground truth.
Amazing. Thank you so much. Kelly, welcome.
Thank you very much. My name is Kelly Forbes, and I am one of the 4 owners of a small human factors company. We're a remote company, so I'm based in Ottawa, but we do have people in a few other provinces within Canada. Our focus is explicitly on human factors, and basically human factors is a scientific domain that looks at the interactions between the human and various systems. And so our focus is always on how do we optimize that, and we tend to represent the operator or the end user, and we look at what some of their limitations are and some of their abilities are. So for us, a meaningful component with this project has been to have an opportunity to work with other companies who are building these systems and taking a look at how to integrate a human within these systems and what some of the challenges are with respect to things like alerting and an understanding of what metrics could be useful in the future to look at indicators of the sorts of behaviors that are out there on the roads every day in terms of aggression, distracted driving, and other safety risks as well.
Amazing. Thank you for being with us.
Hi, my name is Fahed Hassanat. I'm the CEO and head of engineering at Sensor Cortec. And what we do really is we develop AI for perception sensors with a special focus on automotive industry. And I've worked with some of you before, and I share an academic background with Atiq. And throughout my career, I've worked with a lot of data sets, and I've actually went to the degree where I was driving through difficult weather conditions. I was waiting for snowstorms to happen, and I was driving so that I can capture data and see how I can push the sensors of the vehicles to their max. But regardless of what I've done, I've never been as close to what we have simulated and what we have experienced here with the test that we've done recently. When you are trying to simulate a test where you're driving at 50 kilometers an hour, another vehicle is coming at you at 50 kilometers an hour, and you're trying to pass and understand the situation realistically. This is something that I've never felt before. And I realized what is the impact of the technology that we are developing in saving lives.
Thank you so much. We call him the snow chaser. We actually had the Weather Network do a big story, and then it catalyzed all kinds of national coverage. He is the snow chaser. Welcome, Adhikar.
Thank you, Sonia. This is MD Atikur Rahman. I work in the Intelligent Transportation Systems team here at National Research Council Canada. So we have been collaborating with Area X.O and City of Ottawa, especially Omar, on a lot of road and rail safety projects. So this has been our continuation of the previous project with phase 1, where we basically worked on detecting vulnerable road users at intersections and then communicating that information through V2X communications to approaching vehicles. So what is really interesting in this project for us to get involved is we are actually building on top of that and pushing the boundary further to basically not just detecting the current location of the pedestrian on intersection, but also predicting the future path in 1 or 2 seconds in the horizon, future horizon. That 1 or 2 seconds means a lot in terms of safe left turn or right turn, especially for when there will be an AV, because an AV, if it knows in 1 or 2 seconds the horizon of the future horizon of the pedestrian's location, it can better plan its motion path and actually avoid an risky left turn or right turn. Even for human drivers, oftentimes we have right turn on the road, and then if there is a pedestrian that's not really moving, and just getting that pedestrian location doesn't really help, as opposed to if you can actually let the dashboard on the human drivers know that the pedestrian will be on your path when you take right turn on the road, because right turn on the road is always risky. You keep looking on the left for oncoming traffic, and then you take the right turn, forgetting that you also need to have to look at the pedestrians. So when the pedestrian is away from the crosswalk, it really away from the vision of the driver. But if it shows that in 1 or 2 seconds the pedestrian will be on the path of the right turn, that's a lot in terms of adding safety to the pedestrian. So that's really something that pushed us to get involved in building the project idea, starting from the scratch from the project development. We worked with Area X.O closely on that. So thanks for getting us involved on this second phase.
We're very grateful to have the chance to collaborate with all these experts and take a look at the very diverse expertise that was brought together with the $54 million of infrastructure here. That's a powerful combination, and we're looking forward to diving into the outcomes and learnings that you have each contributed to. Kelly, I'd love to start with you. Human factors, driver attention, aggression. There are so many important facets to your work. What would you say are the biggest lessons you've learned about the role of human behavior in road safety and how they can be better integrated into safety frameworks?
Sure, thank you for the question. So when we look at elements related to driver states, such as aggression or distraction, there are really about 3 categories of metrics that we can look at. There's internal metrics such as heart rate variability, electroencephalography, pupil diameter, that look at the driver's response and state objectively. There's also some behavioral measures that you could look at, and then we also have subjective feedback. And so it's a balance between what is the best way to represent the driver's state, but also understand what their expectations are. For when we're looking at developing different designs for alerting, whether it's a visual alert or an auditory alert, all of those factors we have to take a look at to make sure that the information that's coming into the driver is what's expected by the driver, and the driver knows how to handle that information and respond. So I would say in terms of improving road safety, it's really understanding the balance between the system and the feedback that's coming to the human and providing them with an opportunity to be able to respond.
Amazing. And so culminating that together with some of the other partners here gave you an opportunity to do that in a very real world environment.
Correct. Yes, it was very helpful for us to be able to spend some time working within the Lexus and understanding some of the different challenges related to the software development and how that might impact from an implementation standpoint to the driver. For example, if you're receiving an auditory alert and a visual alert, you want to make sure that you have consistency in terms of, is the auditory alert that the person's hearing the same thing that they're seeing on the display, yes, so that there's no difference and the understanding is clear in terms of what's going to happen and what the driver should do.
Such a fundamental element of safety. It's really incredible that you were a part of this project. I'm going to go to Colin because this project brought cutting-edge heavy truck use cases into testing. It gave NuPort the chance to validate how 5G and edge connectivity could support real-time safety interventions for heavy trucks. From your perspective, Colin, what did this project teach us about the role of connectivity in reducing latency and building trust in autonomous braking and driver assist systems?
When we consider autonomous vehicles and we go to a heavy-duty truck, that's 80,000 to 100,000 pounds of equipment. To try and simulate for us at NuPort a safely stopping scenario at highway speeds was one of the integral kind of tests we did here at Area X.O. And obviously, we didn't come into this blind. Our AI stacks and our autonomous understandings had predicted certain kind of factors of how those kinetics and the energy that's going to be generated would affect the distances. The missing link that we hadn't necessarily had was the 5G and the reduction in lag and latency. And so, the findings were, a tap on the back for our tech teams because our digital twins were quite close. But I think we did learn a fair amount with regards to the lag and latency improvements because of the 5G connectivity.
Amazing. We know one of the strengths of this Transport Canada project is that lessons don't stay locked in a single pilot. They become building blocks for broader adoption. Colin, how do you think the learnings of this project, such as validating lane assist, collision warnings, movement assist, how did it help NuPort strengthen its autonomy stack? Because customers and the companies that we serve are really at the heart of Area X.O.
You know, maybe I can go back to the early 2000s when DARPA put that competition out to develop autonomous vehicles. The objective was simple. 94% of all accidents are human error. And that was the challenge. And so the challenge has always been safety. And for our customers, you know, that's paramount. And so that's the foundation that's the foundation on which NuPort has developed our solutions. And so the introduction of 5G was always about reducing the lag and latency as well. Yes, we have edge computing. Yes, we're able to make those compute kind of, changes at a fly. But, what's really important, I think, when it comes to customers, and most of you may know, Canadian Tire has been a close supporter of NuPort from our inception, but we're working in the forestry section, we're working in fisheries, we're working in mining. What this brings to us is not only taking our autonomous technology, but we're now taking the whole package. The team that was here to, pull together by yourselves, it allows us to take and justify the importance of 5G and the multiple kind of nodes that you require in order for you to kind of continue, because fleet managers want to make sure that you're addressing these in real time. And so that's one of the key elements that we felt we got out of this, which was going to be key from a customer standpoint.
Incredible. So we are all about serving companies. We serve them right across the country. NuPort is in Toronto. Alexey, I want to go to you at Bridge Traffic. You worked on optimizing intersections and explored eyes from above. What have we learned about sensor and data fusion between infrastructure and vehicles?
We actually started working with the just regular camera. That was initial idea to use only videos to analyze and to basically implement these safety features just based on a video. But really fast, we realized that's almost impossible. So in the sense that it can be done. Like if you listen to Elon Musk, he will argue all day about using only cameras for Teslas, and it probably can work for California, Austin, Texas, or whatever. But here in Canada, that's not realistic, and that's what we had to implement during that project. Like we did the data fusion with the radar. We can see potentially improving that with the LiDAR as being valuable as well. And that's the lesson that we learned during that project. And on top of that, I can address a latency question that NuPort has experienced. And for us, that's also was a learning. Initially, we were trying to use just compute on camera, just do that everything on the edge and solve everything on camera. But the time that it took to react, it was like almost a second, and this is unacceptable in those real-time scenarios, and especially in safety applications. So we ended up with a on-edge solution. It's a fast-running workstation, basically on right here at this intersection, and that was kind of the unlock where we were able to get those under 100 milliseconds real-time scenarios. So that's one of the lessons that we learned here as well.
Well, we're in a Canadian context, and I see my friend from California here, and so that's snow, sleet, and ice. That is a competitive advantage, and it certainly is something that we need to be thinking about and designing for. How might infrastructure-based safety systems complement in-vehicle systems in Canada's unique climate and conditions?
For in Canada, like what we are looking at is mostly very specific data sets for our conditions that we have here. And that's what we were able to gather here at Area X.O. And I have to thank you guys for this opportunity, because it's almost impossible to get into the infrastructure in real life scenario. Like probably Omar can attest to that, because it's really hard for a city to provide that in a safe environment. So that's why kind of Area X.O is that amazing facility that allows to do that, and allows, as you just mentioned, to do that in a different weather conditions. Also, like what we found, one big difference with the other jurisdictions is that Canadian municipalities, and if you want to run any Canadian project here, they're really concerned about privacy. That's something that doesn't come up in most of the states. Obviously, in Europe, that's an issue as well. But we had to solve for that. So for our project, we had to think about privacy first, privacy by design solution. That's kind of what makes it different for Canada.
Amazing. And working with our city and all the infrastructure you see at all these intersections. We have Omar and the traffic services team at the City of Ottawa to thank for that. So talking about winter conditions, of course, now I'm going to go to our snow chaser, who is very, very passionate about this topic. Your highlighted radar, the unique role it plays in poor visibility is critical. And I know that's one of the things you've tested rigorously here. Why is radar such a critical layer of safety in this climate?
Absolutely. Thank you for this question. This is actually our focus since the inception of Sensor Cortex was working with the radar and understanding how we can leverage the strength. And really, it goes down and back to physics. Radar is a sensor that is robust against challenging visibility conditions. And I believe most of us have experienced this with cameras, maybe backup camera with a little bit of mud on it or splash on it. The visibility becomes very deteriorated, and the sensor becomes non-functional. And I've actually experienced this firsthand with the Lexus. I've driven the vehicle in a snowstorm, and when I came back, there was a layer of ice formed around the LiDAR, which both the LiDAR and the camera are sensors that depend on line of sight. Cameras are passive sensors. They receive the light. So if you block it, there are no information. And LiDAR is an active sensor. It sends out a beam of laser, and it expects it to come back. So if it cannot either send it or receive it because of a physical blockage, then you don't get that information. Radars, on the other hand, if you have a radar equipped vehicle and you try to find it, it's usually behind the bumper. So it is a sensor that works really well with obstructions, with elements that are placed in front of it, because specifically millimeter wave radars, they send a signal that reflects off of objects, comes back, and is not susceptible to obstruction. And that makes it really, really work well in challenging visibility conditions, rain and fog and night, where other sensors fail. So adding on top of that capability, a layer of AI that will able to process the radar signal and produce an object identification and detection, you create a really powerful sensor that might not be a primary sensor, but it can be a very powerful secondary sensor, and it allows you to see in challenging visibility conditions.
Amazing. And I know that you have been working on refining this technology, and we are so proud and honored to collaborate with you. We also chatted in the lead up today about multi-sensor fusion advancing safety in the next generation of ADAS and CAVs. Could you share some of your perspectives on that as well?
Absolutely. I mean, just like Alexey mentioned, Tesla promotes that they can do anything with camera only. And while this is not true fundamentally from a scientific point of view, when the weather is really good, cameras can do a wonderful job. Add a bit of deterioration and add a LiDAR. The LiDAR adds its own strength by detecting depth really, really well to the camera. And you still have a very powerful pair that will allow you to drive in deteriorating conditions. But as the conditions turn worse, and if you only rely on those two sensors, you really have a system that is not operable in deteriorating weather conditions. But add a LiDAR to the mix, a radar to the mix, then you have created a combination of sensors that are complementary to each other, where if one fails, the other complements what the information that is missing, and you have a reliable system that can allow the vehicle, the autonomous vehicle, to go the extra mile. And it's really not about having a 100% experience, because it's kind of impossible. Radars also have their weak points, but it's just about having a graceful degradation of the system. So if you have a system that relies only on line of sight sensors, and suddenly line of sight becomes unavailable, what happens to the system? There is no graceful failure. With a radar in the mix and a sensor fusion concept, you are able to have a graceful degradation and hand over the ability to operate the autonomous vehicle to, for example, a driver, or initiate an emergency situation.
Thank you so much. There's been so much advancement through this project, and I'm very excited. I know, Attica, you and I talked about the data that is being crunched, the analysis. We're not done the project yet, but what would you say, as you've been working on pedestrian path prediction to offset processing latency, what do you think are the greatest learnings from the data you've gathered and analyzed so far from what you've seen?
Yeah, thanks. So our learning so far, as we are still developing the final solution, we have gathered data both from here, the pilot intersection we have. We are lucky to have this intersection. We can generate a lot of different scenarios, and you can grab data very quickly, which is not really possible out. We have, thanks to Omar, we have Omar here. We have public intersections, access to public intersections. So we gather data from public intersections. Oftentimes, I hear that intersection-centric perception. This is a comparatively new concept compared to in-cabin sensing. There is a lot of effort on in-cabin sensing, mainly towards the AV. That's true, that's needed. But in infrastructure-centric sensing, especially for ITS applications, I think it's quite newer compared to this in-cabin sensing. And we see that there's a lot of value when you actually look at the real public intersection data. There were a couple of occasions when you saw that the pedestrian was crossing, left-turning, right-turning vehicle had no way to know because they were completely blocked by large vehicles. And the intersection view, it's a nice vantage point of view for the intersection. It has a global point of view. Not only that, it is the global frame reference for all vehicles passing through an intersection. So it knows each vehicle, knows a single timestamp. It has a single point of view. Not only that, it's also the owner of this pattern map messages. So it can actually combine them together to generate a lot of new things. Yes, we cannot have all the intersections equipped with this kind of technologies. I agree completely with especially Omar. We have 350,000 intersections all over North America, as Omar says. But I think intersection-centric perception is not a nice thing to have, but it's a complementary thing for many situations, especially, dynamic intersections, large intersections with a lot of traffic and the big traffic passing through. So that's one of the major understanding we have had as so far working through the project.
It's such an important topic. What other research gaps do you think remain in terms of data sets, corner cases, ethics, building on some of the insight you've shared? But poor pedestrian intent prediction can be operationalized by municipalities at scale. We're coming to Omar. I saved him last for a big reason, because he'll have heard all the insights from these incredible experts. Exactly.
I mean, these are some of the research we are doing, which we may not need now, but we better be prepared. But when it comes, when AV is there, when autonomous driving is there, we be better prepared with all these tools we have for ITS applications to ensure safety. So one of the biggest obstacles we see, as I was saying, infrastructure-centric research is quite new. There is not much in the public domain in terms of data sets, and that's where I really thank Omar, I really thank Area X.O that are filling the gaps. So far, we have been able to collect quite a bit of data on public intersections and March Road on couple of other intersections in the downtown. That's really the game changer, I would say. And we need more collaboration on this front, and probably from an official point of view, not just Omar fighting alone. Other municipalities, just to create a really diverse view, weather, and scenarios. So that's one of the obstacles I would say as a researcher I have seen. And then of course the corner cases are there. We need all those corner cases to be covered, because I was reading a news, for AV to make a single mistake is not the same mistake for a human driver. It has to be almost 100% correct for the regulars to be happy with. It's good, but the comparison is like this. If you make a single mistake, you lose the trust. So
Yes.
corner cases has to be really, really covered, and there is a lot of work we have to do along that front. So yes, I think these are the two cases or fronts that you should focus more on a collaborative way.
We know those corner cases are going to be essential to achieve the mass adoption, the adoption with municipalities. And it is exactly the reason why I wanted Omar to share his perspectives following all the other experts. As the road owner operator, the municipality, you have emphasized that cities like Ottawa must plan carefully for deployment. You are leading that charge. We're so grateful. What have you learned about the practical challenges of adoption through this project, the fifth Transport Canada project with us, from affordability, prioritization of high collision areas, interoperability across municipalities?
Yeah, thanks. And I appreciate what everybody has said. And I think if I took a little pieces from everybody, right, we don't, as a municipality, have control over the vehicle. That's Colin and his team and his role to be able to make sure that the technology in the vehicle can work. We don't have control of the driver inside the vehicle, but all the human factors that Kelly was talking about is important. We don't manufacture equipment, so things like what Alexey and Breeze and yourself at Sensor Cortex of fusing that data, and then of course the research, right? So the nice thing about working on these projects is, even though we're not implementing all of this everywhere today, we're building the knowledge base of what we need to be able to do to make sure that those edge cases can be dealt with. Because as soon as we started to roll these things out, if we started to have a lot of deaths and collisions, and it's always the autonomous vehicle that is deemed to be the one that's caused the issue, we're never going to get to where we really know that we want to be, and we can be. And that Iker was saying, like, we have 1,200 traffic signals in the signalized intersections across the city of Ottawa. If anybody had a big boatload of money that could give it to me, that I could put out all the equipment that I need, great, but that's not coming, and I don't foresee that coming anywhere in the future. So we have to be selective. And across North America, there's somewhere 350, 360,000 intersections. So, anything that we do as a owner-operator has got to be sort of assistive and incremental towards the vehicle and the technology to be able to work. And so even if we deployed everything here in Ottawa and covered every single intersection, as soon as they get outside of the border of Ottawa, if your autonomous vehicle says, sorry, I can't leave Ottawa because there's no signals information available, there's no sensors that I have, and so forth, it's going to be really hard to sell those kind of vehicles as an auto manufacturer and so forth. And so for us, it's about learning little pieces so that we can put things together. We can start to prioritize where is the intersection where we have the highest left turn collision incidents. What kind of technologies would we be able to use to be able to support improving safety at that intersection, and then be able to do this on I want to call it a piecemeal, because safety is important. We don't want to do things piecemeal, but we have to be selective in terms and be realistic about what we can do. So anything that if the autonomous vehicle can drive without any sort of assistance, that's the ideal scenario. If we can add information like there's a blind corner that you can't see around, but we can tell you that there's a pedestrian coming down the sidewalk, and it'll alert you in advance, that provides the vehicle a little bit advanced knowledge. And if you're a 80,000 pound transport truck, being able to give you that extra few seconds to be able to slow down and stop and prevent an injury or a fatality is anything that we can do. So
Scalability really is one of the biggest challenges in terms of cost-effective scale and efficiency and the ability to serve the entire population.
Yeah, because, you think about it, it was about 100 years ago, we had the very first traffic light. That was one. And then there was two. And now there's 350,000. And if you had one and you said, well, we want to add an extra one, well, you're doubling it, yeah, but it's only two. and people can learn as they go about how the intersection works and that kind of stuff. Now, all of a sudden, we have all this infrastructure that we have to go from a purely analog human sort of world to a fully digital world. It's going to take a transition, and we have to build ourselves towards that future.
So what does that integration path look like? We think about pilots, corridors, citywide policy. We're doing a very large focus in this country, as you know, on procurement, buying local, buying Canadian. We've got lots of Canadian companies on the stage today and a lot of multinational and international companies that we collaborate with, and they all support our economy. What makes sense in terms of adopting the type of transport validated safety messages that came through this project into operations and things like 911 workflows?
Yeah, I mean, I think the biggest challenge really ultimately is some of these are published standards, but they haven't been really proven and tested. So, Alexey was saying, well, we were trying to do it in the camera, but we realized that that's not going to be fast enough, so we have to do something. We may build a message set that says this is the kind of message that you need to provide, but does it have all the information that it really needs? And is all that information valuable? What's the speed at which that information needs to be provided? Right now, our traffic signals, while they are making every 30th of a second, they're making a decision. Is it time for me to start to make the switch to a yellow from green to amber to red? In the reality, there's a buffer that we've already engineered into that, right? A 2.5 second or 3 second yellow time, a certain period of red time. And so for us, projects like this and projects that we continue to work on are building that knowledge base and capability that will get us to where we need to be. And so we have our intersection out in Canada, which is a protected left, 80-kilometer-hour zone. But we are now implementing a new one, which has unprotected lefts, 40 kilometers, a lot more pedestrians, a lot more cyclists in the area. And so that'll allow us and projects like this to continue on into the future to test more and greater things so that we are prepared for when we actually need to start doing larger mass deployments.
Real world environments that we've created together at Area X.O, and it's such a privilege. Collaboration is difficult. This project and every Transport Canada project we've had at Area X.O has had multiple collaborators. What do you think, each of you, I'd love to hear from you, on what you think the true value of collaborating in a constellation like this is? I'm going to start with Alexey.
Yeah, honestly, that's the biggest benefit of participating in that program, being exposed to all of the people and seeing the lessons that people learn in vehicle, and we can actually apply it for infrastructure as well. So this kind of collaboration, and we in this specific project work with the NuPort, and we are thankful for these guys because they were sharing their lessons, we were sharing ours, and that's the biggest probably benefit for us.
Amazing. Colin?
It's I think it's the learning, and I'll describe the team here for us as our neural network. This was beyond rules-based. This was multi-node, which allowed us to learn because, yes, we get opportunities. We've got a project with a mining company in Alberta, and we're on private roads, and the road is 67 kilometers long. And so there is a lot of distance and space there. But, we don't have Omar's traffic lights. We don't have some of those real-world scenarios. And so I think by being provided Area X.O as the test bed, and then this neural network of working with the latest technologies in all 4 climates as well. This isn't just sunny California. This is winter Canada as well. So
yes,
I think bringing all of that together for us is valuable because of neural networks, we are getting closer to that level of autonomy that we've all read about or dreamt about. So I think this makes us get there closer.
Step by step. The shared learning lifts all boats. Yes. Wonderful.
I think for us, every time we have an opportunity to collaborate with other companies, it helps us learn. It helps us be better at the things that we do. It helps us to develop new techniques and new tools that ultimately contribute to the overall body of knowledge as we advance these systems. And I think the other thing that is so helpful for us is it expands our network, but it helps us to understand some elements of human nature, speaking from a human factors perspective, that haven't really been brought to the forefront before. We haven't had to think about things in the same way, and it gives us an opportunity to do that within these types of collaborative settings.
I love that, and I agree. We need more focus on human factors. Absolutely. Ahead.
Yeah, I want to affirm what Colin mentioned, and just add a little bit from a software company point of view. We are very busy behind our computers, little screens, and our data sets that we, without realizing it, we become siloed. We are developing a problem that we only see that is a problem. But the opportunity to collaborate with other companies allows us to see what is the impact of other technologies on ours and our technology on others, and seeing things from a different perspective. While I might be designing my system for a very low latency, if I can integrate it in a general system that does not respect that, I have not solved the problem.
Yes.
And with this team, I was actually able to get great insights into how we can, integrate our system successfully in a
Amazing.
in a
So it
more,
enhanced your
production.
business. It allowed you to do
Absolutely.
more within your company.
Absolutely.
We love to hear this. Yes. Edgar.
Yeah, for us, it's clear. We have been collaborating with you for 3 years now, and
Yes.
that's the greatest value we see here as a research organization. We really need these facilities for us to drive the research to the next level. As I already mentioned, data, and that's a big front from city, from Area X.O, and the facility here. We can come and test anytime our algorithms here, and we can actually validate that on real-world data from city. And also, we've been collaborating with SMEs like Fire Sensor Cortex. That's where we basically gain knowledge where the industry is heading to, and we can basically generate ideas, because we are a research organization. We always think we need to think ahead of what's coming next, and that's where these collaborations with the SMEs and the facilities we get access to through city, through Area X.O is super for us. And it's been 3 years we have been collaborating on different projects. You can tell how important it is for us.
We love bringing the community together, the local community, the technology community, Canada's and global communities. Omar, you've been a collaborator for an awfully long time. So why do you keep coming back and joining us?
Either I'm crazy or I love what I do.
Which is amazing.
And maybe sometimes a little bit of both, right? I mean, I was just thinking, when we started basically, let's say 7.5, 8 years ago, we had a traffic signal in the middle of a farm field that no one ever, this was an abandoned place. I don't think anybody driven it. There was grass, like grass had grown halfway. There was no, it was like, what are you doing putting something here? And to see what it's become, to see the collaboration, the working together, the research, the knowledge that's sharing, all of that is really just part of the reason why I love doing what I'm doing, and love working on these kind of projects. Because as much as I'd love to think that I know everything, I don't, right? And bringing really interesting, smart people together to work on a problem, to figure out that next step, will get us to where like I said before, where we want to go. We're not there yet, but as we work our way through these issues and challenges and problems, and figure out these nuances that we have to do because of winter weather, because we have freezing rain, all of these other things that kind of happen, we will get to a point where, my mother, who's been dealing with dementia and can't drive, could actually get into a vehicle and it can take her to her doctor's appointment, or bring her to my house and be able to have dinner with me. And right now, I got to go pick her up and bring her to my place. Fine and dandy, but the loss of mobility, the loss of the freedom of people, and the ability of what autonomous vehicles will bring is substantial. And so, keep on coming back to do more.
It's the great equalizer. Mobility is freedom, it's life, and I believe that that's what these technologies are providing. I'm going to ask Omar one more question before I invite my panelists to think about one key takeaway they'd like to leave the audience with. Omar, in this world where we really are thinking about how we're putting learnings to work and these technologies to work, could you describe one way, could be any of the Transport Canada projects we've undertaken, where you've actually implemented something or made a change at the city, or you've seen a meaningful difference in applying that knowledge?
I think probably the one where we're looking at is the vulnerable road users. We haven't yet done anything with our rail crossing, and part of that is we actually don't own the rail crossings. That we have 68 of them here, level rail crossings across the city. But I think on the vulnerable road users, right, we are constantly looking at how we can improve safety at our intersections. And one of the newer technologies that's coming about is LiDAR. And there's a company that has a 360 LiDAR that provides a view of the entire intersection. And so we've been starting to look at how we can actually use that to be able to detect where pedestrians are, detect where the vehicles are. We're not yet at the point of being able to provide a warning to people. You know, there's always legal liability, sort of those kind of things. But as we move forward in understanding what the capabilities are, there may be a way that we can actually turn a light green earlier or later, for depending upon which way we're dealing with a pedestrian crossing the road illegally or just being stuck. Maybe it's an elderly person walking across the street that we need to be able to extend the green to be able to allow them to get fully across the road. Those are kind of things that we're looking at, and these sort of newer technologies, as opposed to just the physical detector loops in the ground, allow us to do a lot more than what we can today.
Amazing. All in the name of safety. Safety is our North Star. I know it's the North Star of this project team. I'm going to invite each member of the panel to share one key takeaway they would like to leave to you. And of course, today's being recorded. So this panel discussion is going to share your learnings very broadly. I'm going to start with Alexey.
Since it's only one, I'll choose the importance of getting the right data set for fine-tuning for a specific use case, for a specific geography. That's not obvious, but if you just travel a lot and you see, a fleet of vehicles in China versus fleet of vehicles in Australia and Canada, that's not going to be the same. And obviously, as we discussed thoroughly, the weather conditions will be different. Side of the road, there are many things that can affect that, and gathering that data set is actually a huge challenge, as anybody who did the computer vision project can attest. And as I mentioned, the privacy is also a big concern in some jurisdictions, not in all, but definitely in Canada, that's something that you have to consider while you're doing fine-tuning for a specific use case.
Amazing, thank you. Colin?
At NuPort, we're testing. We did some great tests last year in snow. You would have loved it. And they even threw logs on the highway in the test to really prove out what the conditions of the sensors were and if the vehicle was able to see them and therefore stop. I think what's unique about Area X.O is the 5G, and it is the reduction in lag and latency. And so I think one of the areas that really excited the team was the learning from this project on what our digital twin and our simulations were predicting versus what's actual. And I think it's that takeaway for us to now go back and crunch and to be able to kind of align the math, which has been really important. Because now I think it helps us to further tune, or for the AI stacks to further tune, the stopping or the left turn information that we learned from this.
Amazing. Excellent. Kelly?
I think for my sort of key takeaway here, I'd like to draw a link between the value of simulation and the factors that you can assess or investigate that can make your operational road test more effective, so that it reduces the risk associated with operational testing, but that it also reduces the time required, because you can work out a lot of things in simulation that you don't necessarily need to do. And I think the value of that is also tied to the trust in automation and looking at how to build trust in automation so that your end user ultimately has a better experience and a more reliable experience with the system.
Amazing. Excellent. Ahead.
From my perspective, I want to make 2 points, if I may. Sorry. But the second one is going to be about you, Omar. So I think one thing that we have to be, and I'm very grateful for this, and I believe everybody on the panel is the value of Area X.O and the effort that Invest Ottawa has put into this. This facility has been traditionally monopolized by OEMs. where they would test their own vehicles, they would get their own data, and they would put that into their own car. What this facility did is technically democratize that information, democratize that value, and allow small SMEs like us, that we've tried before to approach OEMs with our technology, and we were told that we're developing this in our own playground. Well, this is our playground now, and thank you, Invest Ottawa. And the second thing that I want to highlight is the importance of an empowered municipality. And I can say, and I'm not saying this to your face, Omar. I'm saying this in front of everybody. So I've collaborated with Omar on a project where he actually went after hours, put on a hard hat and a reflective jacket, opened up a cabinet for me so that he can support my work. And to see a municipality go that far to help an SME develop their technology is absolutely fantastic. And I think this is a really, really great direction. And I want to push for it towards, to get even larger.
Collaboration is the underpinning, honestly, here in Ottawa. I love this city, and this is why. It's exactly this. Thank you.
I think the key takeaway message that I can leave here well resonates with what Omar already mentioned. Whatever technology we design, safety has to be at the center of it. And as a research organization, we are really up to research into enhancing safety, especially pedestrian safety at intersections, because we all are pedestrian or VRUs at one point in time. If we are out of the car, we are pedestrians, we are on the street. And whatever technology you design, it has to basically ensure safety of pedestrians, especially at intersections. And statistics says 21% of pedestrian fatalities occur at intersection. So definitely research in this direction has to be prioritized. And we really see, needle being pushed by City of Ottawa. They are actually pursuing research results, bleeding edge technologies to be, deployed on intersections. We appreciate that, and we want this kind of initiative be, followed more and more across the municipalities.
Amazing. And we're going to bring it home with Omar. It's the perfect way to conclude this panel.
I was going to say, you did say this is recorded, so
Yes,
I can
it
share
is.
that because my boss isn't here, so they didn't hear all the good things that Fahad said about me. I think the biggest thing really is what you see here on the panel, right? Bringing together, and I've mentioned this before, bringing together good people who want to move forward and develop something is really important. We can't, as a municipality, do this alone. Area X.O can't do this alone. It requires a team to be pulled together. And so projects like this, with the work that Transport Canada, the funding that they provide for the ERSTPP program to help this thing move forward, is really what's crucial. And I'm most thankful for that.
We're incredibly grateful to Transport Canada for supporting this project. I'm grateful to my amazing colleagues, Rebecca, Suzanne, Pablo, Ethan. These are the teams that put these proposals together, that design them, and then bring this amazing group of leaders together, and they oversee the execution together with them. Thank you all so much for being here.